Burj Khalifa's foundation, the hidden engineering that holds up the world's tallest building. When people look at the Burj Khalifa, they see the world's tallest building. An architectural masterpiece soaring 828 meters above Dubai's skyline. But the most important part of the tower isn't visible at all. It's hidden beneath the ground. Because before engineers could build the tallest skyscraper on Earth, they first had to solve a critical problem. How do you support a structure weighing hundreds of thousands of tons on loose desert soil? This is the remarkable story of the Burj Khalifa's foundation. Most supertall buildings rely on solid bedrock for support. Engineers simply anchor foundations directly into strong rock formations below the surface. But Dubai presented a very different challenge. The city sits on layers of sand, weak sedimentary rock, and groundwater. There was no deep granite bedrock available to support a skyscraper of this scale. Many believed constructing a building this tall under such conditions would be extremely difficult. The solution required some of the most advanced foundation engineering ever attempted. Engineers began with an extensive geological investigation. They drilled deep beneath the site to study soil layers, groundwater conditions, and load-bearing capacity. After analyzing the data, they designed a massive piled raft foundation. This system combines a huge concrete foundation slab with dozens of deep foundation piles. Together, they distribute the enormous weight of the building across a large area. The foundation begins with a giant reinforced concrete raft. This concrete mat is several meters thick and covers thousands of square meters beneath the tower. Its purpose is to spread structural loads evenly and prevent excessive settlement. But the raft alone wasn't enough. To provide additional support, engineers installed 192 reinforced concrete piles beneath the building. Each pile extends approximately 50 meters into the ground. These piles act like giant anchors, transferring loads into stronger soil and rock layers below. Together, the piles and raft create a highly stable foundation system capable of supporting the world's tallest structure. But supporting the weight wasn't the only challenge. Groundwater presented another serious threat. Dubai's underground water contains significant levels of dissolved salts and chemicals. Over time, these substances can attack concrete and corrode steel reinforcement. If left unprotected, the foundation could gradually weaken. Engineers needed a long-term solution. One of the most innovative features was the use of a cathodic protection system. This technology is commonly used to protect pipelines, bridges, and offshore structures from corrosion. The system works by directing a controlled electrical current through the reinforced concrete. This process significantly reduces corrosion of the steel reinforcement inside the foundation. Essentially, it protects the building from the damaging effects of groundwater for decades into the future. The concrete itself also required special engineering. High-performance concrete mixtures were developed specifically for the project. These mixes offered exceptional strength, durability, and resistance to chemical attack. Even pouring the foundation was a major undertaking. Thousands of cubic meters of concrete had to be placed continuously to ensure structural integrity. Careful temperature monitoring prevented cracking as the concrete cured. Once completed, the foundation became one of the largest and strongest ever constructed for a skyscraper. But the true test came when the tower began to rise. As floor after floor was added, engineers constantly monitored settlement and structural performance. The results were remarkable. Despite the enormous weight, the foundation performed exactly as designed. The tower remained stable and secure. Today, visitors admire the Burj Khalifa's gleaming exterior, record-breaking height, and breathtaking observation decks. Few realize that the building's greatest engineering achievement may lie hidden underground. Without its sophisticated foundation system, none of the record-breaking architecture above would be possible. The Burj Khalifa stands not only because of what engineers built in the sky. It stands because of what they built beneath the earth. A foundation designed to conquer loose soil, resist corrosion, and support one of humanity's greatest construction achievements. Invisible to most. Essential to everything. And one of the greatest engineering success stories of the modern world.